Let's talk about safety. We developed the PULSAR platform to be safe because we are in the medical field and safety is a priority. And also because these robots are meant to be used close to people or in contact with people, so you don't want them to get hurt. So to make the PULSAR platform safe by design, we decided to implement redundancies at different levels. First of all, at the level of the joint, we have the local redundancies. Inside this joint, for example, which you can find in the robot here, approximately, you will have redundancies with two brakes, two different encoders, also two collision detection systems, and also two integrated controllers which can monitor the joint in real time, and also they both have the same power of force to stop the robot, in fact. Then we have the global level of redundancies, which is about the control of the joints as a robot. So we have two controllers controlling the joints, and each controllers are doing the same motion calculation, and if the two controllers does not agree, the robot stops. And the two controllers are also checking each other's state and each other results to be sure we execute the trajectory the customer asked. And also to allow the system to know exactly what the customer wants. The customer has two pipes of communication, so he has to send the same command to the two controllers separately, and then we are sure that there is no problem in the communication. With all these redundancies, we can ensure there will be no unintended movement from the robot.